Welcome once again to this YouTube channel. I appreciate everyone for subscribing to this channel, and I appreciate as well if you share this video with your friends so that they can also learn from content like this. In this video, we are going to be solving questions from the Cambridge IGCSE Chemistry, an extended paper, the multiple choice, and it's simply May, June 2023, and the variant is 21. So let's go straight into the questions. All right, the first question gives us a diagram that shows the result of dropping a purple crystal into water. So upon dropping the purple crystal into water, after 5 hours, the color of the solution changed to purple. So we move from colorless to a purple solution. So the question says, which processes take place in this experiment? Now, we look at the options and we eliminate the ones that are not in line at all. So if you look at option A, remember that for the purple crystal to change the color of water, it must have dissolved. So look at the option, which one cancels out dissolving? Option A and option B. So these two options are off because they do not represent what has happened in this process. Because for the purple crystal to change the color of the solution must have occurred. So we are left with option C and option D. Now, for the purple color to move all the way from the bottom of this solution up to the top, that process is simply called diffusion. Okay, so the color diffused from a region to another region, and that is what makes option D the correct answer. All right, so that is how to adopt the process or the concept of elimination to save time. Which rule about elements, mixtures, and compounds is correct? We are going to apply the same thing here. Metallic element. Brass is not a metallic element. It is an alloy. So it cancels out. So we have two options already off. We are left with two other options. Now, we move to the second part, non-metallic elements. Of course, methane is a compound. Okay, so that means option A is equally off. That means the correct answer here is option C. You can see that elimination is helping us move very fast with solving questions like this. It will save a lot of time because this paper is just for 45 minutes. Now, the next question, the atomic structures of four particles W, X, Y, and Z are shown. Which particles are isotopes of the same element? For two elements to be isotopes, they have the same atomic number but different number of neutrons. So let's look at the options that we have. Which of these particles have the same number of protons? We have W, Y, X, and Z. Okay. Now, if they are to have the same number of protons, they should equally have the same number of electrons. So if you look at the options again, which one has the same number of electrons? We see Y and Z have the same number of electrons. So what differentiates them is the number of neutrons. 2 here, 3 here, and this is what makes them isotopes. So our answer here is simply option B. So we go to the next question. Which statement explains why isotopes of the same element have the same chemical properties? Now, for elements of which are isotopes, that is, they have the same atomic number, but they should have similar chemical properties because they have the same atomic number. Okay, so what differentiates them is the number of neutrons, but they have the same atomic number. And for them to have the same atomic number, they should have the same chemical properties and they should belong to the same group in the periodic table. So if you look at all the options, this one says they have different number of protons. That is off because that is not what isotopes represent. Okay, now the mass numbers doesn't affect the properties, chemical properties, so that is off. So what makes them have the same chemical properties is the fact that they have the same number of outer shell electrons, and that is what determines the group. So they belong to the same group, and that is why they have the same chemical properties. All right, so question 5. Nitrogen forms a nitride ion with the formula N3-. Which particle does not have the same electronic configuration as the nitride ion? Now, the proton number of the nitrogen is 7. So if nitrogen has a proton number of 7, to get the number of electrons in nitrogen or the nitride ion, it becomes the proton number plus the charge on it, because it's negative, so it becomes 10. So this 3 minus charge means it's receiving 3 electrons. Okay, so that means the nitride ion in this case has 10 electrons. So we are going to look at each of these options to see which of them doesn't have 10 electrons, and that becomes the answer, because that is the particle that does not have the same electronic configuration as the nitride ion. So if we want to write the electronic configuration of this, we can simply say 2, 8, okay, following the number of electrons in that nitride ion. So let's obtain the number of electrons for aluminium. Aluminium has atomic number of 13, but there's a 3 plus charge. And because it is positive, it means it is giving out 3 electrons. So it becomes 13 minus 3, and that is 10 for aluminium. We go to chlorine. Chlorine has a proton number of 17. It is receiving 1 electron, so it is 17 plus 1, and that is 18. Sodium has proton number of 11. Okay, now it is giving out 1 electron, that is the plus charge, so it becomes 11 minus the 1, which is now 10. And then oxygen has the proton number of 8, so 8 plus the 2 in oxygen equals to 10. So all of this and this will have the same electronic configuration as the nitride ion, except the chloride ion. So that's how to solve that. Now we go to question 6. Which role describes the formation of single covalent bonds in methane? Now, when we talk about covalent bonds, we're talking about sharing of electrons. So anything that is different from sharing of a pair of electrons, those options are off. So option C is off because it involves transfer. Option D equally is off because it involves transfer of electrons. So we're left with option A and option B. So this part of these options are very correct because they share a pair of electrons. Now let's go to the other part. Both atoms gain a noble gas electronic structure, and then option B says both atoms have the same number of electrons in their outer shell. That is, this is not always possible for both atoms to have the same number of electrons in the outer shell. It's not the case always. So option A is the answer in this case because they both attain a noble gas electronic structure, and that's what makes them stable. Now question 7. Which formula is an empirical formula rather? Which formula is an empirical formula? Now an empirical formula shows the simplest whole number ratio of the atoms in the molecule of the compound. So if you look at this is C2H4O. Now, can we have a number that can divide all through these numbers? That is, can we have a number that can divide 2, 4, 1? That number is not existing, okay? So that is off. Now, look at the second option. Can we have a number that can cut across everything? Yes. So we have a number that can cut across all of these numbers. We can use 2. By the time we use 2 to divide all through here, this formula is going to change to C2H4O. Okay, so this makes it not the empirical formula because the empirical formula has to be the simplest whole number ratio of the atoms in the molecule of the compound. So if we go to the second one, this formula is simply the same thing as C3 plus 1, C is C4, and then H7 plus 1 is H8. Okay, and then there are 2 oxygens, so O2. So it is just like this one. So 2 can divide all through, and this is not the simplest whole number ratio of the molecule of that compound. The same thing applies to this one. It is not the simplest whole number ratio. So the best answer here is the first option because that's the simplest whole number ratio of that molecule of the compound. All right, let's go to question 8. Okay, so for question 8, we're trying to see heating iron sulfide in air produces sulfur dioxide. Okay, the equation of the reaction is given. What is the maximum mass of sulfur dioxide produced from 120 kilograms of iron sulfide? Now, we are working in kilograms. That means we have to convert most of the masses to kilogram. And remember the conversion from kilogram or gram to kilogram is 1,000 grams is equivalent to 1 kilogram. So that's the conversion rate. All right. Now, first thing you need to do in questions like this is to get the stoichiometry of the reaction. Now, in this case, 4 moles of these are reacting with 11 moles of oxygen, 2 moles of iron, 3 oxide is formed, and then 8 moles of the gas is equally formed. Okay, so we are asked to compare. Now, what's the maximum mass of sulfur dioxide produced from 120 kilogram of iron sulfide? So the two things we are comparing here are this iron sulfide and sulfur dioxide. So what we need to do after getting the stoichiometry and knowing what we are comparing is to get the molar masses of the two compounds we are comparing. So let's begin with iron sulfide, FeS2. So if you check your periodic table for the atomic masses, iron should be, I think iron should be 56 plus sulfur is 32, so 2 times 32. So if you use your calculator in this case, we're going to have 32 times 2, which is 64. So 64 plus 56, that is 120. So 120 grams, okay, per mole for iron sulfide. So we do the same thing for sulfur dioxide, SO2. So sulfur is 32, oxygen is 16, so 2 times 16. So that's 32 plus 32, that's 64 gram per mole, or 64 gram as the case may be. Now that we have gotten the molar masses of the two compounds we are going to be comparing, since we are working in kilogram, the next step is to convert them to kilogram. So if you convert 120 grams to kilogram, it's more like saying 120 divided by 1000. So that is equivalent to, so the molar mass of iron sulfide is 0.12 kilogram according to the conversion. So equally convert the 64 gram to kilogram, so 64 divided by 1000. So I have for sulfur dioxide, I have it as 0.064 kilogram. Okay, so now that we have converted to kilogram, we're now going to bring in the stoichiometry of the reaction. So how many moles of iron sulfide produce 8 of this? So this is what we'll do. 4 times, what is the molar mass of the iron sulfide? 0.12 kilogram. Remember, the 4 is simply the value of iron, of the number of moles from the balanced equation. That's simply following the stoichiometry. So 4 times 0.12 kilogram produces 8 times, what is the molar mass of the sulfur dioxide? So 0.064 kilogram. Okay, so that's the first statement we make. 4 multiply, the 4, remember where the 4 is gotten from the stoichiometry. 4 of these, what is the molar mass of iron sulfide? 0.12 kilogram is equivalent to 8 times the molar mass of the sulfur dioxide, which is 0.064 kilogram. Okay, so what will now be the maximum mass of sulfur dioxide produced from 120 kilogram of iron sulfide? So we are simply saying, what will 120 kilogram produce? So this becomes X. Okay, so from your knowledge of cross multiplication, so we're going to do 4 times 0.12. Okay, so 4 times 0.12, so that is 0.48x. So 0.48 will be used to divide all through. So 8 times 0.064 times 120, okay, so divided by 0.48, and that gives us 128 kilograms. So B is the answer to this question. All right, so that is how to solve questions like that. Okay, so you can watch it over and over again to get how it was done. All right, so we go to question 9. Which substance produces hydrogen and bromine when electrolyzed? Okay, so let's pick out the options one after the other and explain them. So for first option, concentrated aqueous copper 2 bromide. So we are looking at something like this. Copper 2 bromide is something like this. So if it's aqueous, so we are looking at the ions in the solution are copper 2 plus for the cation and hydrogen ion, and then bromide ion and the OH minus. Okay, so for hydrogen to be produced at the cathode, okay, if you look at this, in terms of reactivity, hydrogen is more reactive than copper. If you look at the reactivity series, so hydrogen remains in the solution while copper is deposited at the cathode. So anything that contains copper now is off because this option is not true. Because in option A, it is copper that is deposited at the cathode. So not hydrogen. Okay, so let's go to option D. Let's examine option D. Now, option D, molten lead-2 bromide. Molten lead-2 bromide doesn't have any trace of hydrogen because it means that lead-2 bromide was heated. So when you heat lead-2 bromide, what we expect is Pb2 plus and then the bromide ion. So we can't find anything like hydrogen as the ions in this case, and that's what makes this option off, because it doesn't contain anything hydrogen. It's not an aqueous solution. Okay, so we move to the next one, dilute aqueous potassium bromide. Okay, dilute aqueous potassium bromide. We also have concentrated aqueous sodium bromide. So for the case of dilute aqueous potassium bromide, of course we have more of the hydrogen concentration there. Okay, and that would simply mean that we are going to have B as the answer to this question, because in the case of concentrated aqueous sodium bromide, sodium is simply more reactive and therefore hydrogen is deposited at the cathode. So B is the answer to question 9, to save our time. For question 10, which statement about hydrogen fuel cells are correct? So for question 10, let's look at what we have. Water is formed as the only waste product. Okay, that is correct for that. Both water and carbon dioxide are formed as waste product. No, that is what makes this is a greenhouse gas. So why we adopt the use of hydrogen fuel cells is to eliminate the use of greenhouse gases. So option 2 is off. So anything that has 2 is off. Now the next thing is the overall reaction is endothermic, and the other one says the overall reaction is this. So for both of them, this no, the overall reaction is not endothermic. So we'll have with 1 and 3. So that is for question 10. Now let's go to question 11. Ethene gas is completely burned in excess oxygen to form carbon dioxide and water. The equation for this exothermic reaction is shown as seen there. Okay, and then you're given the table that shows the bond energies of the bonds that are likely to be there. So we're expected to use the information to calculate the total energy in this reaction. So we're going to break this down as simple as possible so that we can move forward from this question. So for us to break this down, what we're going to do is to draw the ethene structure. Now ethene structure is something like this. Okay, so if this is the ethene structure, so pick your calculator and follow through. Now, from the CC bond, we have just one carbon double bond. So we have one carbon double bond for the ethene. Oh, before we move into the breakdown of the energies and how we can compute it, for an exothermic reaction, okay, it is simply the energy required to form the bond minus the energy required to break the bond. Okay, so the energy is simply going to be this, the energy of the reactant, for it to be an exothermic reaction minus the energy of the product. Okay, that is how we are going to obtain the change in energy in this case. So if we follow through, let's get that of the reactant first. So that of the reactant is ethene plus oxygen. So ethene is what we are trying to compute. So for ethene, energy of the reactants now, for starting with ethene, we have just one carbon double bond. So that's 614. Plus, how many carbon hydrogen bonds are there? So we have 1 here. So this is the first carbon hydrogen, second carbon hydrogen, third carbon hydrogen, 4 carbon hydrogens. So there are 4 carbon hydrogen. And what's the bond energy for carbon hydrogen. So it's 4 times 4, 1, 3. Oh, that is clear. It should be 3 oxygen, double bond oxygen. So when we add that up, we should not have 5, 2, 3, 6 like I earlier said. Sorry for that mistake there in computing, just trying to make sure I hasten up. So it's 3751. So this is the energy for the reactant. Okay, so we have computed the energy for the reactant. 614 because there is just one carbon double bond. 4 into bracket 413 because the carbon hydrogen bonds we have there are 4 of them. Okay, in the ethene compound. And then for oxygen, the O double bond O, there are 3 of them there. That's why it's 3 times 495. So obtain 3751. So let's go to the product now. Let's compute the energy of the product. And remember that when we do that, we'll now come back here to use this formula because it's an exothermic reaction. Okay, so for the carbon dioxide, okay, we have that the C double bond O, okay, we have 799. But how many C double bonds O do we have? So it becomes 4. We have 4 C double bond O's here. So for the products, for the energy of the products, we have 4 C double bond O's. So that becomes 4 into brackets 799. Okay, plus. Now for water, how many OHs are there? Okay, how many OHs are there? So it just becomes 2 times these 2 here. So we have 4. So we have 4 OHs in this case. So 4 OH. So that's 4 into 4, 6, 7. So let's compute again. 4 into bracket 799 plus 4 into bracket 4, 6, 7. All right, so I have, in this case, I have 5064. So kilojoule per mole. So we're going to use this and this now to compute our final answer. So it's going to be 3751 because that's the energy of the reactant minus that of the product, 5064. So by the time you subtract, so it's going to become 3751 minus 5064. So if you use your calculator, what I have here is minus 1313 kilojoule per mole. Okay, and that is how to compute that. Okay, so watch it again to get what was done in the question, and be careful of how to pick out the bonds. Question 12. Which role describes the effect on the activation energy and the frequency of particle collisions when the temperature of a chemical reaction is increased? So you should know that when the temperature is increased, the activation energy is increasing, and then the frequency part of the collision is equally increasing. So this is a straightforward answer. So it is simply A. Now go to question 13. Solid copper 2 sulfate exists in 2 forms, anhydrous and hydrated. One of these forms is blue and the other is white. The change between these 2 forms is reversible. So what is the blue form, and how is the change from the blue form to the white form brought about? Now you should know that the blue form is the hydrated one. And for you, since it is hydrated, by heating it, the water evaporates and then you obtain the dry salt. So D, because the salt is hydrated and that water molecule can be removed by heating. Question 14. Sodium ions and oxygen ions combine with chromium ions to form a salt. The salt sodium dichromate has the formula this. What is the oxidation state of chromium in this salt? Now, sodium is in group 1, so it has +1. So 2 into bracket +1 plus, the unknown is chromium, but there is a 2, so it becomes 2 chromiums, plus oxygen is always -2, so we have -2. So we compute this 2 plus 2Cr, since it's a neutral compound, so 7 times -2, 7 times -2, that is -14. So we have 0 equals to this becomes minus 12 plus 2CR. So 2CR is equal to plus 12. So divide all by 2. So CR is plus 6. So that's option C. So plus 6 is the answer. All right, we go to question 15. I believe we are progressing gradually. The concentration of hydrogen ions in 100 centimeter cube of 0.1 mole per dm cube hydrochloric acid is higher than the concentration of hydrogen ions in another acid with the same volume and the same concentration. So which statement explains the difference in hydrogen ion concentration? Now, this is just the difference between a strong acid and a weak acid. So the answer should relate to what we talk about strong and weak. So ethanoic acid is an organic acid. That's not the reason why there's a difference in hydrogen ion concentration. Ethanoic acid has a lower pH than hydrochloric acid. No. Ethanoic acid is a strong acid. No. So ethanoic acid is partially dissociated, and that is the truth. That's the correct answer, because it is partially dissociated, it doesn't have enough hydrogen ions concentration. Okay, and that is why there's a difference in hydrogen ion concentration, because ethanoic acid does not dissociate completely in water, unlike hydrochloric acid, which is a strong acid and dissociates completely in water. Question 16. Which oxide is classified as amphoteric? Now, this is a simple question. It's simply aluminium oxide. Okay, you know what we talk about metal oxides, and we talk about non-metallic oxides. So the metal oxides are basic, okay, and the non-metallic oxides are acidic. Which method produces the salt copper 2 carbonate? This is question 17. So let's read the options. Add copper 2 oxide to water. Okay, you form the hydroxide likely to add excess sodium carbonate to filter out the precipitate. Okay, let's note this option. Let's go to option. Add copper 2 oxide to nitric sulfuric acid. Okay, so the sulfuric acid dissolves it to form copper sulfate, all right, and water. Then you add excess sodium carbonate, okay, which would precipitate it out. Okay, this is also a good suggestion. Add copper to dilute hydrochloric acid. Copper and hydrochloric acid, that reaction likely not occur because hydrogen is higher, so it's difficult for copper to push off hydrogen that easily. Add copper 2 oxide to excess sodium carbonate, aqueous sodium carbonate, and filter off. So in this case now, option B is the correct one, because the copper 2 oxide would not dissolve completely in water. Okay, it's insoluble in water, so the best is to add it to dilute sulfuric acid to make it a bit soluble before you add excess aqueous sodium carbonate that will precipitate it out. Which statement about the trends across the period of the periodic table are correct? So we're going to read each of them and see. So it says aluminum is more metallic than sodium. No. Okay. Remember that the group 1 metals are more reactive than the group 3 metals. Okay, so that is off. So anything that involves 1 is off. So we just eliminate A and B. So we're left with B, C, and D rather. So beryllium is more metallic than carbon. Okay, yes, that is correct. Boron is more metallic than aluminium. No. Magnesium is more metallic than silicon. True. So option C is the correct answer. So we go to question 19. In question 19, we are given some information about elements in group 2 of the periodic table. Okay, and then which row shows the correct trends in reactivity, density, and melting point of the element going down group 2 of the periodic table. So as we go down group 2, what do you observe about the time taking for hydrogen gas? You see that the time taken for hydrogen gas to be given off is decreasing. Okay, so it's decreasing. So we see that as we go down the group, because the time taken is decreasing, it means the metals are more reactive. So as we go down the group, there is an increase down the group. The increase in the reactivity with cold water increases. So every option that involves decreases is off down the group. So we are left with option C and option D. So if we go to density, the density is 1.85 for beryllium, 1.74. It's more like decreasing to 1.54. Then when it gets to strontium, it rises up to 2.62. And then when it gets to barium, it rises up to 3.51. So there's no clear trend for the density. Now let's look at the melting point. Melting point moves from 1280 to 650, decreasing. Then it increases again, then it decreases, and then it decreases. So in this case, we can't simply say there is a clear trend for the melting point. So our answer is simply option D, because that aligns with the fact that there's no clear trend for density and no clear trend for melting point. A new element, oxfordium, was discovered with the following properties. In which group of the periodic table should this new element belong? Now, we see that the solubility of the element is insoluble in water. Okay? It doesn't conduct electricity, which makes it not a metal. So, because it's not a metal, we might simply cancel out group 3. Because group 3 are majorly metals. Okay? Majorly metals, and there are some, of course, some might argue that it's not all metals, but it's majorly metals in group 3. Okay, and then we go to the fact that, for the fact that it doesn't conduct, makes it not a metal. So the formula of the element is diatomic. Now, for such element to be diatomic, let's take note of that, is bonding in a molecule of, so this is the bonding, it forms triple bonds. So what elements are likely forming triple bonds? You can remember, those elements are always in group 5. Okay, they're always in group 5. They are likely going to form triple bonds, and they're also diatomic. They're also diatomic in nature. An example is nitrogen. Nitrogen is diatomic in nature, and it's triple bond. Its bonding in a molecule is triple. Okay, 21. Which rule describes the similarity and the difference between chlorine and bromine? Okay, so let's read through these options so we can eliminate anyone that does not align. Both are gases at room temperature and pressure. Chlorine and bromine have different colors. This is correct, but this one is no. Both exist as diatomic molecules. This is correct. Chlorine is more dense than bromine. That's not possible. Both have atoms with 7 outer shell electrons. This is correct. Only bromine will react with aqueous sodium chloride. That's not possible. Okay. And then option G, of course, should be the answer, because both react with aqueous potassium iodide because they displace iodine here, and chlorine is more reactive than bromine. So this is correct. So we go to question 22. Which statement describes transition elements? Of course, we know high densities and high melting points. So we shouldn't take time on that question. Which gas is made when powdered zinc is added to dilute hydrochloric acid? Now, zinc is higher than hydrogen on the reactivity series, so it's expected to displace hydrogen to form the salts, and then hydrogen gas is given off. So 23, answer should be C. This is simply a displacement reaction. Okay, so the diagram represents the structure of a solid. Which solids does this diagram represent? Now, when you see a diagram like this, having particles in a pattern that their other particles are meant and introduced to distort this arrangement, so that these atoms do not slide easily over each other. What should come to your mind is an alloy. Okay, so only alloys are arranged this way. So which option looks at alloys as a priority? So C and D off. So we are looking at A and B because brass is an alloy. So we'll look at it again. We see that only option B fully portrays what the diagram represents. So option B, okay, because this is not graphite and this is not sodium chloride. 25. Steel is an alloy of iron. Which statement explains why steel is stronger than iron? So steel contains carbon, which is very hard substance. No. The carbon atoms in steel bond together very strongly. No. The carbon atoms in steel make the iron atoms bond together very strongly. Still no. So the carbon atoms prevent layers of iron atoms from sliding over each other. This is correct. 26. 3 students X, Y, Z are told that solid P reacts with dilute acids and also conducts electricity. The table shows the students' suggestions about the identity of P. Which students are correct? Okay, now they are told that this solid P reacts with dilute acids. Okay, now if it reacts with dilute acids, that means the metal part of it should be able to displace hydrogen. So copper is off because copper will be unable to do that in this case. So every option that has copper is kind of off. Okay, so we are left with just two options, iron and graphite. So graphite, of course, we know conducts electricity, but does it react with acid? Of course, no. So our answer is iron. So 26 is C. Now go to question 27. Which statement explains why aluminium appears to be unreactive? Of course, it's because it forms an oxide layer, okay, that protects the metal. Now, during electrolysis of aluminium oxide, the mass of the carbon anode changes. Which rule describes the change and gives a reason for this change? The mass of the anode decreases because the carbon reacts with the oxygen produced at the anode to form carbon dioxide. So 28 is A. 29. Several processes are used to treat domestic water. So which rule identifies a reason for the given process? Now, the essence of chlorination is not to remove impurities, is to kill germs. Okay. Filtration is to remove insoluble solids. Yes. Sedimentation to remove soluble solids. No. Use of carbon to kill bacteria. No. So option B is the answer to this. Question 30. What's the equation for photosynthesis? Of course, this is a straightforward answer. So B is the answer to that. 31. Which statement describes how the carbon-hydrogen bonds in methane gas in the atmosphere contribute to global warming? Now, I know methane gas is a greenhouse gas. So what it does is that it absorbs thermal energy from the earth, and then it emits some of this energy towards the earth. So that is option D. Okay, question 32. The structural formula of two hydrocarbons are shown. Which statement about the hydrocarbons is correct? Okay, they are both alkenes. They colorize aqueous bromine. They are structural isomers. They undergo addition reaction. Now, if we look at it, remember that the alkanes have the general formula of CnH2n plus 2, and the alkane CnH2n. Okay, so how many carbon atoms are here? 1, 2, 3, 4. So we have C4, H10. So in this case, how many carbons? 1, 2, 3, 4. And how many? This is for the alkanes. We're trying to see if they are actually alkenes, but we're going to use the general formula for alkanes to test. Okay, so if we count for the second one now, it's 4 carbon atoms. But how many hydrogens are here? 3 plus 1, 4. 4 plus 3, 7. 7 plus 3, 10. So they contain equal number of carbons and equal number of hydrogens, which makes them not an alkene, and they would not decolorize aqueous bromine, because only alkenes can decolorize aqueous bromine. So what we have here is, of course, this is off, so they are structural isomers. Okay, the same molecular formula, different way or different structures of representing them, different ways of representing them rather. Question 33. The structural formula of compound XQ is given rather. What is compound Q? So this is an ester, and how do you name an ester? You name this part first, then you name this other part. Okay. So if there are 3 carbons there, we are looking at propyl. Okay. So everything butyl is off because there are 3 carbons after the ester group. So it's propyl. And how many carbons are before the ester? So 1, 2, 3, 4. 4 carbons. So we are looking at propyl butanoate. So 33 is option C. Propyl butanoate. The fractional distillation of petroleum is shown. Which fraction contains hydrocarbon with the longest chain length? Now, the one with the longest chain length will take a higher temperature for you to obtain. So the one with the longest chain length will have a higher temperature, and therefore it will come below the fractionating chamber. So the answer here is simply the one at the lowest, which is D, because it takes a higher temperature to get to this point. 35. Which equation represents the cracking of an alkane? Now, when you crack an alkane, Two likely products you're going to obtain is you're going to obtain an alkene and a smaller alkane. You obtain an alkene and you obtain a smaller alkane. So if you look at these options, this is off. You're supposed to have two products, off. This is the correct one because this is the alkane. This is the smaller alkane and this is the alkene. So this is D. Now, 26. What is the structure of the product of the reaction of propene with bromine? Now, this is an addition reaction. So, whenever an halogen reacts with an alkene, the two bromides are, when you look at the structure of propane, it's kind of this, like this. Okay, let's create the halogens here. So, 1, 2, 3, 4, 1, 2, 3, 1. There's one up here. Please bear with me. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Okay, so this is propane. All right. Now, when the bromine goes in, what the bromine does is it breaks the double bond. Okay, it breaks the double bond and it attaches itself to the carbon in between these double bonds. So one bromine is going to attach itself here and the second bromine is going to attach itself here while the bond breaks to a single bond. So we're going to have a bromine here and a bromine here. So that's what happens in this addition reaction. The bond is broken to a single bond and then the first bromine attaches itself to the first carbon in between these two, the double bonds, and then the second one. So if you look at this product, which one aligns with that diagram, you see that is option C. Okay, so this is the first carbon and this is the second carbon in between. That's if we are drawing the double bond at this point. So that's for that. Question 37. In reaction R, 2000 molecules of this react to form a single molecule X only. So 2000 of that, which term describes reaction R and X. So what kind of reaction is reaction R? Of course, this is a polymerization reaction. So in this case, you know that the reaction is an addition reaction because there is a single product formed. In an addition reaction, only a single product is formed. Then this is the monomer and your product is the polymer. So this. But unlike in condensation, you have a second product. But in addition, just a single product. Now, part of the structure of a polymer is shown. Which statement about the polymer are correct? Now, this is not a nylon polymer. That is one thing you need to know. So, this polymer is formed by condensation polymerization. Okay, there are extra linkages between the monomers. Okay, in this case, we don't have extra linkages here. So, only option, the polymer is formed by condensation is the correct one here. So we get to question 39. The concentration of acid and alkalis can be determined by titration. Which pieces of equipment are needed to perform the titration? So of course, you want to perform titration, you need 4 and you need 2. So that's D. The last question here, which chromatogram shows how the RF value of a substance is calculated? Okay, distance moved by the sample divided by the distance moved by the solvent. So if you look at these options, which one represents the distance moved by the sample? Okay, Y, and this moves distance moved by the solvent. Okay, that's this. So if you look at others, they are not that way. Okay, so it should be distance moved by the sample Y over distance moved by the solvent. So for this, it is B. Okay, so this is the end of this paper. I believe that you've learned something. So what I want you to do is to watch the video over and over again to learn how some of the answers are gotten. And if you have any questions, just put it in the comment section. Thank you once more for subscribing. Please continue to share this content so that your friends can also learn. Thank you and enjoy the video.
I want to talk about a very important YouTube channel called Ajiro Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE. Trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you are giving to them. Thank you very much, and I'll see you in my next video. Bye bye.